website. All right, so let's get the show on the road. So tonight we are starting with the topic of functions. And if we talk about this unit on functions, we're basically going to do tonight's lesson is going to be about straight line functions. And then the other 5 lessons are going to be about what we call quadratic functions. Now, in the holidays, we're going to do a separate unit on exponential and hyperbola, but really these 6 lessons are going to be about these. Today, we're going to focus on straight lines, but all the fundamental things about straight lines that you need to know. And a lot of these fundamental things can be applied to other types of functions. So we're going to talk about input-output pairs. We're going to talk about the standard form of a straight line function, gradient, intercepts. And I'm just repeating these words so that your brains are starting to go, all right, I remember that. I heard that once. We're going to talk about intersection points. We're going to talk about f of x notation. I actually want a quick little poll. Who's used f of x notation? Give me a thumbs up if you've used it before. Give me a thumbs down if you've never used f of x notation. Okay, it's not fancy, but it's just when we deal with functions, we often see like f of x equals something or g of x equals something. And we need to make sure we get comfortable with that notation. Okay, I can see a lot of students need a bit of help with that, which is, don't worry, me and Yolanda will sort you out. We do both love functions. So then the other thing I want to also talk about tonight is if you want a point on the line or you want a point off a line, do you know how to get those points? And then I'm actually not going to spend too much time with parallel and perpendicular lines. We covered that a lot in our analytical geometry lessons. So if you are a little bit rough at that, I would recommend you check out our lessons on analytical geometry, where we did a lot of straight lines. And that's why tonight we're only doing 1 lesson on straight lines before we go to quadratic functions. Okay, so enough talking from me. Basically, the guiding question for tonight. Do you know how to find all important information related to straight line functions? So I suppose important information is a broad term, but that's what I'm going to attempt to show you. So let's do an example. Now I'm going to do the first example, and then I'm going to ask you guys to do a second example. Could we hit mute all, Yolanda, just so that there's a bit of, okay, so very first example. In this, the next 2 questions are going to be exactly like this. And so have a think about the structure. I've given you a straight line in this question with 2 points, A and B. And we are going to find the gradient, the equation of the line, and the x and y intercepts. So that is, remember the guiding question is, can you find all the important information about straight lines? Now I'm going to do it for you, this first one. So you don't need to do anything here. I'm just going to model it for you, and then you will do this in the second part of the lesson. So because I know that the gradient has a formula, I'm going to start by writing down my gradient formula. And what I always have to remember is it's change in y over change in x. Okay, so I do that and I go to my points. I choose either of the points. It doesn't matter which one I choose, but I have to be consistent. So since I'm starting with this one, 7 and 1. So I'm going to go 7 minus 1. And then for the next one, I'm going to go to x, and I start at the top again, go down to the bottom, and now I'm going to get 4 minus 2. And so 7 minus 1 is 6. 4 minus 2 is 2. I say the gradient is 3. This makes sense to me because I can see that the line is sloping up and to the right. It's ascending, it's going up. So I'm like, good news for me. If it was negative, bad news for me. Okay, so that's step 1. Step 2 is find the equation of the straight line. And in this case, there are 2 different methods that students like to use, but both methods need a gradient and they need a point. So we've got our gradient is 3. And in the one method, what we like to do is, I'll call it method 1, is M1, is we write down y equals 3x plus c. Now, the standard form of a straight line is y equals mx plus c. And so I've just replaced the m with the 3 that I found above. Okay, now I've got the m, but I don't have the c. In order to get the c, I sub in one of the points. And to me, the simplest looking point is the smallest one, which is the point 2, 1. So I'm using the point 2, 1. Now what I'm going to do is I sub that in. Which one is y? I know that, let's use a different color. This is y. Oh, that's not a very nice color. It doesn't contrast. So I know I have to replace that bit. And then over here, I know I'm going to replace that bit with that one. So I get 1 equals 3 times 2 plus c. And now I get that. However, what I need to do is I need to get c by itself. And so in order to do that, I need to take away 6 from both sides. And if I do that, if I take away 6 from both sides, I get minus 5 is c. And so my final answer is going to be the straight line is 3x minus 5. That is what we call method 1. I'm going to do method 2, which is some students will do this. In this case, what I do is I go y minus something equals the gradient x minus something. Oh, let me move this out the way. Okay, so this is the method. The second method is you go y minus something equals 3, well, basically it's the gradient, and then x minus something. And all you're going to do is, as that something, you are going to use the point that you choose. So in this case, I'm going to get y minus 1 here and x minus 2 there. Once I've done that, I'm going to simplify by multiplying out. And then all I need to do as the final step is take the 1 across. And what is minus 6 plus 1? The good news for me, everyone, is it's the same answer. Okay. What I realize is I need to give you some time to practice this. So I'm actually not going to do the intercepts yet. I'm going to come back to do that. I want to give you a chance to practice what I just did. So what I'm going to do is I'm going to zoom out for a second, and I'm just going to show you another question, which was almost exactly the same as the last one. And I want you to try and do that for yourself now. But I'm going to leave the working out that I've done on the screen. So let me even make this a bit bigger. So what do I want you to do? I want you to find for me the gradient of this line, this other question I've just shown you. And I also want you to find the equation of the straight line of the one that I'm showing you. So basically, it's the one with the green stripe on top. I'm leaving the example that I've just done for you here so you can use it to help you. Okay. Now, I know I've done a lot to start with. I feel like a little bit like I've been like, boom. So what I would like is, while some students are working on this, I want those of you who feel like, look, you were a little bit quick now, to raise your hand, and I'd love to have a conversation with you about this question. Okay, so just raise those hands. And for those who are feeling good, just get going on doing the second question. And you're finding the gradient and the equation of the line. Okay, Bontle, if you could unmute yourself, let's have a conversation. Hi, Bontle.
Hi, sir.
Can you hear me?
Yes, I can hear you, sir.
What is your question, Bontle?
My question is, for method 2, where does the equation come from?
Okay. Now, what I would recommend, Bontle, is I wouldn't use both methods every time. I would choose the method that suits you best. Okay. So don't choose a method and become like a specialist. So, but in the second method, where does it come from? It comes from the gradient formula. So if you think of the gradient formula, it looks like this. Now, what would happen if you moved the bottom part to the other side? Well, you just get m times x2 minus x1. And so it comes from that formula. Does that help, Bontle?
Yes, thank you, sir.
But yeah, you can use whatever way works for you, but that's where that formula comes from.
Okay, thank you, sir.
Pleasure. Who else has a question? Masego, let's come to you. Masego, what's your question? If you click the block at the bottom, Masego, you should be able to unmute yourself. It's like a little pop-up. Okay, I'm not sure if that's working, but yeah. And students, as you get your answers, don't be afraid to pop them in the chat. So if you've got a gradient answer, pop it in the chat. Fantastic. And then for those students who, what I want you to do is I want you to think, how would you find the intercepts for these two lines? Could you find the X and Y intercepts as a challenge? So if you finish early, I want you to try and find the intercepts of these two lines, the X and Y intercepts. But most of us are definitely rather focusing on the fundamental idea here. And then so I agree with all of you in the chat that the gradient is -6. So now the question is, of these 2 points, which one looks easier? To me, the point 1, 1 looks so much better. So I am going to use method 1 and write down the standard form of a straight line with my gradient filled in. And then what I'm going to do is I'm going to say, look, I want to use the point 1, 1. And so I'm going to write it down. And now you need to sub in and solve for C. Okay, where does the 7 come from? Naledi, you want to know, where does the 7 come from? What part of the question are you referring to? Also, remember, Yolanda will help you in the chat if she can. The 7, Naledi, in the first part of the question comes from, yeah.
Sorry, Naledi is referring to the second question on how did the other students found 7 as C.
Okay.
We haven't done the corrections yet. We normally wait for Teacher Peter to confirm with the answers and then we can move on.
Yeah. So I'll do the second bit for you. So I'm not going to do both methods this time, but I'll switch between the 2 methods tonight and I'll use them. We should always get the same answer. So if I sub in, now I'm subbing in this point 1. Oh, here's your 7. Here we go. I get 1 equals minus 6 plus C. So I have to move my minus 6 to the other side. Now, what do I do if I get minus 6? This minus 6 times 1, it has to get moved to the other side. It becomes 1 plus 6. And so we know that the final answer is minus 6x plus 7. And what's more, that makes sense to me because it's got a positive gradient. Okay. Now, what I want to do is I want students to help me find for both of these questions the x and y intercepts. Okay. So first of all, I want you to check, did you get minus 6x plus 7 as your straight line in the second question? And in the first question, did you get 3x minus 5? Assuming you got those, to find the y-intercept, what do we need to do? One of my students can tell me. I see so many hands up. Amo, let's come to you. How do I find my intercepts?
Sir,
yeah.
I wanted to ask about how you found y. What did you do?
Okay. Go ahead. What do you want to ask?
Sir, I wanted to ask how you found y.
Which y in particular? Which part of the question?
So did you substitute this -6?
Yeah. So I took the -6, which is at the bottom, and this is my gradient. And I subbed that in to the standard form of a straight line, which is y equals mx plus c. That's why all of a sudden you see that yellow -6. Then
okay.
I took the point 1, 1 and put that into it as a substitution. Okay. So guys, I'll do it as an example and then you can mimic it for me. To find the y-intercept, you simply have to make x 0. And so in the first one, the y-intercept is just going to be -5. If we wrote it as a coordinate, it would be 0, -5. To find the x-intercept of a straight line, we have to do the opposite thing. We have to make y 0. And so we would then get the equation 3x minus 5. Let me just move some of my other stuff out the way because it's just getting in the way. Luckily, I do have a infinite canvas, and so there is plenty of space. So we get 0 equals 3x minus 5. I then get 5 equals 3x. I divide both sides by 3. Oh. So I divide both sides by 3, and I get my x coordinate as that. And so my x-intercept will be 5/3, 0. Now, what I would like my students to do is I want you to find the x and y intercept for the second example. I want you to prove to me that you can find the x and y intercept for the second example. Over to you guys. While you do that, I'm going to take questions from the class. So, Itumalang, I'm coming to you. What is your question?
Oh, good evening, sir. So
Hello.
I wanted to ask, why are we substituting x as 0? I mean, y as 0 into the x-intercept if it's not cutting the x-intercept?
Okay, good question. Let us look at the graph above. If you're asking me, where is the x-intercept? Now, you actually can't see it in this drawing, but if you imagine, would you agree that the x-intercept is where my big red dot is? Can you see that? Can you see my big red dot? Okay, now at the x-intercept, what you notice is that y is always equal to 0. So whenever you're at the x-intercept, you're in line with y equals 0. And that is why when we're finding the x-intercept, we make y 0. So I hope that helps with your question. Okay, let's have a look at the chat and see if students are managing to find the x and y intercepts for the second one. So what I'm going to do now is I'm going to use the same trick as last time. I'm actually going to write y-intercept so I don't get confused. And for the y-intercept, I make x 0. So some of you may even want to write underneath it to remind yourself x 0. So what do we get? Well, anything times 0 is 0. So we get 7. And then in coordinate form, we get 0, 7. So that is my y-intercept. What is my x-intercept going to be? Who can maybe help me? Who's feeling brave enough to take me through how to do this? So, Abongwe, are you willing to help us out with the x-intercept?
Yes, sir. I
Go ahead.
said it will equal 0 equal -6.
Can you talk through the steps? Talk me through the steps from this point now.
Then I moved the +7 to the left to make it a -7.
Okay, and then?
Then I divided -6x with -6. And what we do on the right side, we do on the left side.
Perfect. So you then got x is 7 over 6.
Yes, sir.
I agree with you. And so what is the coordinate going to be then for the x-intercept?
7 over 6, comma 0 in bracket form,
Yeah.
so that we have bracket and. But
So I just
had
wanted
another-
to,
Well done.
I just wanted to test that you knew where the zeros go, because sometimes students forget for the x-intercept and the y-intercept where the zeros have to go.
Yeah.
So you had another question?
I wanted to ask if I didn't say my y-intercept is x equals 0 and I said my y-intercept equals c, would I be wrong?
Y-intercept equals what?
C, the value of c.
Okay, it depends on the question. If the question was asking for the coordinates, then you would lose 1 mark. If it just said y-intercept, it's not wrong to just write like y equals 7. It just depends on how the wording goes. If it asks for the coordinate, you need to give the blue one. If it doesn't ask for the coordinate, you can just give the one in yellow. Does that help you?
Oh, okay. Thank you, sir.
Pleasure. Okay, now, one more question before we go to our break here is I want to show you how to write a straight line in f of x notation. Now, it's not very exciting, but I want to know that you can do it. So if I said to you, I want you to write my original straight line in f of x notation, all I do is I take the original and I change the y to an f of x. And then on the other side, I write 3x minus 5. Not very exciting, I know. But what that is doing is it is basically giving us a name for a particular function. And when we have lots of functions in the same neighborhood, we really like to give them alphabetical names like the f of something and the g of something. And so that is translating it into f of x notation. Now, the other thing that's really useful about f of x notation is if I say to you, what is the value of f of 4? All that means is what is the value of the function when x is 4? Or what is the value of the function f when x is 4? And so the f of 4 would simply be 3 times 4 minus 5, which would be 12 minus 5, which would be 7. So in fancy mathematical writing, the f of 4 is 7. Okay, now what I want is I want you to write, apologies for all the zooming in and zooming out. I want you to write the equation or the straight line equation y equals minus 6x plus 7. I want you to write that in f of x notation. And then I want you to find me, the value of, so I'll put it here. I want to, first of all, write the straight line f of x notation, and then find me the value of the f of 2. Over to you guys. And I want to see those answers in the chat.
Let's do this, guys.
Let's do it. So again, remember we're doing the green one. And I'm writing that same straight line function in what I call f of x notation. And then I'm asking you, what is the value of the f of 2? Okay, Orwa Tiwe, I see your hand is up. Do you have a question? I'm coming to you. How can I help?
Good evening, sir.
Hello.
Sir, can I ask, how would they ask this question if it was ever to come up in an exam or test?
So it's not really going to be asked like I'm doing it now, but what I want to make sure is students understand the language. So to be honest, it's kind of hard for me. I'll have to show you later in the units, but basically I want to make sure students understand what it means when we say the f of 2, or when we name a function, the function f. Students often find that quite overwhelming, and it doesn't need to be. So for example, let's look at this. The f of x in this case is minus 6x plus 7. Now that wasn't very fancy. Basically, all I did was replace the y with the value f of x. But what is nice about this notation is it gives me a way to say what is the value of the function when x is 2. And all I need to do is sub in a 2. And so what do I get then? I get minus 12 plus 7. And then I get minus 5. And so we say the f of 2 is minus 5. Now, guys, I've got a question for you before we go to the break, and I know we deserve a break. I've been a bit naughty here. I've called two functions f, and that can get confusing because I have two f of x's on the same page, which strictly speaking, it's not the best idea because which f am I referring to? What do you think I could do instead of calling it f of x? What would maybe have been a better idea to call the second function? Does anybody have an idea? I see Notile's hand is up. Notile, do you have an idea?
Yes, sir.
What do you think I should have done? Maybe, yeah.
G of x or g at x.
Yes, I instead of using, so even though we call this f of x notation, what I should have done is to prevent ambiguity, I should have called it the g of x, and then I could have said, what is the g of 2? And mathematically, in order to make sure we don't get confused, it probably would have been better to use a different letter for a different function. But often when we talk about, we say f of x notation, but you can actually use g, you could use h, that's completely fine. So if you understand the naming of a function with f of x and g of x, just raise your hand, or sorry, give me a thumbs up. If you feel confused by this naming, give us a thumbs down. So g of x and f of x is the same thing. It's not the same thing. It's just a way of naming functions. So the function f on the board right now is f of x is 3x minus 5. So that's one straight line that you can see above. It's a positive gradient. It goes up. But the g of x describes the graph directly above, and that slopes down. And often students don't, with the moment they see g of x or f of x, they're like, what is going on here? And you don't need to be like that.
That's true, because we used to y equals to.
Exactly. And it really, all it is a substitution. Okay, I've been talking a lot. It's time for a brain break. So what I want you to do is, I want you to stand up and just do your favorite stretch for just 30 seconds. And while you do that, Yolanda is going to be handing out shout outs for the best stretch.
Yes, guys.
Will be a scale, artistic impressions, commitments, etc. And I just want you guys to get up. I'm going to stretch. And then after we've had a stretch, we're going to do a little brain break quiz thing.
Woo, okay. Oh, I see you over there.
Felisanda?
Bali.
Don't worry, we'll get there. Okay, let's have a break. Let's stand up and let's stretch it out. Oh, that feels good.
Not Chile. Oh, guys. This is nice. Yandiswa. Woo, go, go.
You can do it. You can do it. Oh, it feels good. I feel so much happier as a human now that I stand up. I really, your brains are like, oh, I can do a second part of the lesson now. I feel fresh.
It helps a lot.
So while you are still standing up and thinking, here is your brain break for the day, I have taken it down a notch. The last one, maybe we got a little bit too excited. But see if you can solve this brain break. Nontokozo, I see your comment. Felisanda, we will definitely carry on practicing and repeating. So don't worry. Also, there are some very good videos on Watobe about straight lines. And so if you're feeling like, oh, the pace is just a bit much, I really recommend having a look at those videos. Okay. Okay, so I see lots of people say orange is 10, which I completely agree with. Now, what else do we need to do? So that is 5. I agree. Now, what is half a triangle going to be equal to? And do you know your BODMAS? Haha. So triangle, yes, because we need to get up to 13. I agree. So what's the final answer going to be then? Who knows the final answer? Be careful. There's something called BODMAS, which is gonna, you've got to keep your eyes on the prize there. So BODMAS says, which of these two operations get done first? Addition or multiplication? I think it's multiplication. So we get 10 plus 10. And so the final answer is 20.
Well done, guys. I saw a lot.
Lady, Omfa, and Tukozo, and see how well done, guys. I think lots of you, Rachel, I see lots of you got that right tonight. Fantastic. Cool. Now, what I'm thinking sitting here is how good was that stretch? Oh my gosh. If you didn't stretch, you missed out. I highly recommend that you get some stretch in your life going forward. This felt so good. Okay, now let's move on to a second type of question. So let's look at something like, let's do this one. So I'm going to give you the following question, and I want you to try and do the first 3 questions first. And then I want you to try, I'm going to talk a little bit about the last one now in a moment. But basically, I want everybody to try and do these first 4 things. So the gradient, the equation of the straight line, the x and y intercepts, and then put your graph in f of x notation. And then for those who are feeling like on fire, I want you to figure out a point on your line and a point off your line, if you know how to do that. And then for students who are, if you are feeling like, yo, this man is just going way too fast, what I want you to do is I want you to either raise your hand and let's have a conversation and we can work it out, or you can put it in the chat and Yolanda will help you. But don't just sit there. Use the resources that are available to you. We would love to help you. Okay. And then for everyone else, I want you to just get the show going and see if you can remember from earlier in the lesson how to do this.
Let's do this, guys. Let's do it. Remember, to everyone who's new, that we have all the lessons recorded, so you don't need to worry. We've got you.
Got your back. So what I'm going to do is, just to help you, I'm going to write the stuff that is on the formula sheet. So whenever you do an exam, you probably know this, you have a formula sheet. And so I will just put the stuff that's on the formula sheet up there for you, just to help you along the way.
Teacher Peter, is it fine if we say that point -2 and 5 is A, and then point 1
Yeah.
and -8 is B? There we go. Now you have your answer. Tokozo.
So you raise a really good point, excuse the pun, is that it really helps to have labeled your points, right? The moment we don't label our points, it gets a bit confusing. And so that's why in maths, we often use capital letters to label a point, because otherwise we don't really know what we're talking about. So Yolanda, that was great. Thank you. The only thing that I find always catches me is making sure I keep the order consistent and my Y's go on top and my X's go on the bottom. So that is what I always watch out for. I always double check myself, just in case I've made a silly mistake. So what do we get? We get -4. There's a couple of different ways you could write it. -4 and 1/3 is what I get for my gradient. Some of you, although to be honest, when you do a calculation, guys, it's actually much easier to leave it in improper form. So both are correct, but if you're reusing something, your calculator is a big fan of the improper form. I see a couple of 13/3s, but we should be a -13/3, huh? So just watch out for that. If you haven't got a negative, you may have made a silly mistake. So you should have got for your gradient 13/-3, or -4 and 1/3, or -4.3 recurring. My tip is to leave it in improper form. I think that if it's a fraction, it's easier to work with in improper. Now, in the last question, I did method 1. So in this question, I'm going to do method 2. And that starts by basically using this formula. But we still need to find the gradient, and we still need a point that we sub in to the thing. So that would be method 2. Method 1 would be to write down y equals mx plus c, and then also having another point that we use along. Maybe I'll just do both for today, since I'm depending on time, see how much time I've got. Okay, I've given you a little bit of a hint. Now, what is the I'll call that method 2. This is method 1. I suppose I have to choose a point now, and I normally go with the point that looks easiest. It's not really obvious. You don't know, which point do you think looks easiest? A or B?
Always the smallest numbers. I think for me it looks easier, but because I have
Let's go with -2.5. I think
Yeah.
-5 looks like the easiest thing. And now in method 2, I do need my point, and I need to be careful because I'm actually going to have, okay, y minus 5 is all good, but then the x is going to be minus 2. And I suspect a couple of students might get caught out by that minus 2. And also, don't be afraid of your calculator, especially when you get fractions. It can be very helpful to have your friend, the calculator. In fact, let me do an extra line for this. We get, this should become x plus 2. This is a little bit of a harder one, and that's why I gave it to you, because I felt like after our warm-up, I need to stretch you a little bit. So, now what do we get? We get minus 26 over 3. What I like to do, guys, is when there's a 2 there, I can sometimes write it as 2 over 1. It just helps me a little bit. Now, what's my last step going to be? I'm going to wait a little bit of time and wait for students to think about, but I definitely know that I would be a fan of using my calculator in this one. How do we get the 2 yellow things to play nice together? Let's go back to the beginning.
I'll use a calculator.
Yeah, because
But
basically,
I finished.
yeah, I basically put my green one in, I put my gradient in, and then I put my points in. And then I had to do a little bit of this. This became x plus 2. So that was a little bit sneaky. And then I had to multiply this out, which was also a bit sneaky. Okay, so now the last step is I need to add 5 to both sides. And if I use my calculator for that, because I think it's too late in the day for me to be using too much brain power, I should get minus 13 over 3x, and then I should get minus 11 over 3. If you want to write that in proper numbers now, you could write it as minus 4 and a third x minus 3 and 2/3. So that would also be correct. Now, that was a little bit trickier. And so I want to know, are there questions from students before we do the last part, which is finding the x and y intercepts? Both of these answers are equivalent here. I'm sure there's questions. Who would like to ask a question? I feel like I can feel that students are a little bit, they need a bit of help. David, go ahead.
So where did you get the -3 2/3 from?
-3 2/3. Okay. I just converted 11 over 3 into what was called a mixed number. So David, how many times does 3 go into 11? It goes 3 times. And
Yes,
then
sir.
2 left over. So, but you don't have to do that one there.
Sir,
Yeah.
is it a must for me to what you call this, write it in improper fraction?
No, you don't have to. It's up to you. I'm just showing you how, because the moment they're fractions, I know students get confused. And so I want to make sure we do an example that gets that in the way. Okay, now let's try and find the x-intercept and the y-intercept. If students are confused though, I would love to assist where I can. So please raise your hand. Remember, for the y-intercept, you make x naught. And for the x-intercept, you make y naught. So to me, what I'm noticing is that whenever I sub that naught in, it actually knocks out the x term. And so I can actually see the answer for this is straight away going to be -11 over 3. Or in coordinate form, it's going to be naught -11 over 3. You may have picked this up in the lesson. Look at how whenever I substitute x as naught in, the y-intercept is always this. In fact, let me take this color here. In my equation, the moment I make x naught, the y-intercept is always that last bit there. And so we can actually, we don't even need to do any working out. Notile, I see your hand. Can I help you?
Yes, sir. My question is, I can't understand the question that says a point on or off the line using fx notation. What does it mean? What are we required to do?
Okay, so if a point is on the line, when you sub, can I get to that in a second? I'm going to finish the lesson with that. But all I'm going to say is, if you sub something into the equation, it will be on the line. So, but I'll come back to that in a moment. I just want to finish this train I'm on, and we'll come back to it. Okay, let's find the x-intercept. To find the x-intercept, we make y naught. So then I get -13 over 3x minus 11 over 3. Now, guys, I really recommend that you use your calculator with this one, because there's lots of fractions. You don't have to get it wrong, but it will be your friend if you use your calculator. So watch this. I'm going to take the -11 over 3 across. And what am I going to get? I'm going to get positive 11 over 3. Okay. Now the thing that is getting in the way, the thing that is making my life difficult, is -13 over 3. So what I'm going to do is I'm going to divide both sides by -13 over 3. Now, there are other ways of doing this. I understand that. But basically, if you can put that into your calculator, do that now. Go. 11. So 11 divided by 3 divided by -13 divided by 3. Your final answer for x should be -11 over 13. What is my intercept going to be? My intercept is just going to be -11 over 13, 0. So take a moment to see if you're working out is the agrees with me. And what I want to know now is, if I wrote that in f of x notation, well, we've already established f of x notation is just going to look like that. And so now we come to this idea of, how do we know if a point is on or off the line? Well, one of the ways of finding a point that's not on the line would just be to look at the graph. So you can see from the graph, there are no points in the first quadrant that are on this graph. So one point that I could choose that's clearly not on this line would be the point 1, 1. Because 1, 1 is in quadrant 1, and I can see that the graph doesn't go into quadrant 1. So that's the one way of doing it. Now, how do I get a point on the line? Who would like to tell me, if anybody's feeling brave enough, how do we get a point that is on a straight line? Or Latiwe, I'm coming to you. Can you unmute? How do we find a point that's on the straight line?
I'm so sorry to disturb you, but I got lost on the question on finding the ingredient. I'm a bit behind, but I couldn't find the right answer.
Okay, no, it's fine. Let's go back and work through it. At the beginning of the next lesson, I will go through points on and off the line. I think most students would benefit me going through this again one more time. So where did I lose you?
After the whole dividing situation, I just keep getting the wrong answer.
Dividing situation. Okay. In the x-intercept, is that what you're talking about?
Yes.
Okay. So let's start by writing out my equation. Minus 13 over 3x minus 11 over 3 equals 0. Are we okay on that?
Yes, sir.
Okay. Now, I'm going to move my minus 11 over 3 to the other side, and I get positive 11 over 3. Are you okay with me on that?
Yes, sir.
Perfect. Okay. So we've only got one more step to go. All I'm doing is I'm dividing both sides by minus 13 over 3. Why do you think I chose minus 13 over 3? Do you think there was a reason?
To cancel out to get the x.
Yes. The reason I chose that is I absolutely had to make sure it was the same as the yellow thing above. So now all I'm left with is, can I work out with my calculator how to do this? So let's do it together. In our calculators, there's different ways of doing it, but essentially I need to go 11 divided by 3 divided by minus 13 divided by 3. So in my calculator, if I do that, I get minus 11 over 13. Now, it might be that your calculator is going a bit wonky there. Is that where I'm losing you?
Yes, sir.
Okay. So you just need to practice that step. And then the last thing is, if it's the x-intercept, it'll always have a y value of 0. So I think it's just your calculator. You must just practice keying stuff into your calculator.
Yes, I got it done. Thank you.
Perfect. Okay. Are there any other questions before we end the lesson? I'm going to pick up in the next lesson about the point on and off the line. Actually, let me just explain one little thing. Basically, if you want a point on the line, all you do is give it an x value and it will give you a y value. So let's say I choose the x value 2. If I want another, you can visualize this by going to the graph and going, here is x is 2. Now I want to know what y value goes with 2. The good news is you have a function that tells you its only job in life is to say, give me an input, I'll give you an output. So we say, what is the f of 2? It's just going to be a 2 plugged in where there's an x. And this is where, again, I want to get my calculator out. And I'm just going to go minus 13 divided by 3, which was already there, times by 2 minus 11 divided by 3. And in this particular case, this was a lovely example with lots of fractions. I get minus 37 over 3, which if I wanted to, I could write that as minus 12 and 1/3. And so a point on the line that I have just found, but you didn't have to do this one, you could have used another value, is the point 2 minus 12 and a third. Okay, so just to summarize, how do you find a point on the line? You simply sub an x value in, the function gives you a y value, and now you found your point. To find a point off the line, what I showed you was you can visually see a quadrant where your line doesn't go, so you just pick a point there. There is another way, but I'll talk about that in the next lesson. Okay, so guys, I'm going to call it for today. I think we've done enough revision of straight lines. And I just want to say, well done. You really, really did apply yourselves in the lesson, and yeah, you did good work. If we could just end by doing a poll, I'd like to get a sense from the students if they found the pacing was about right today. How did you find the pacing overall? It's just helpful for us to keep the lessons helping as many students as possible. And yeah, well done. I hope that you have a great exam tomorrow if you're writing, or a great day. And thank you very much, Yolanda, for your help.
Thank you. And all the best to all of you students. Oh, you guys were lovely people today. I hope you learned. Remember, if you are still confused, we do have this recording, you know, in 24 hours. I think it's ditchy.
Cool. Sihao, I see your hand is up. Can I help you before we finish off?
Yes, sir. Oh, never mind. So I thought it was negative 27/3. I wanted to ask if could we write it as -9 instead of -12/1/3. I didn't see that it was 7.
Yeah. Cool. Fantastic.